boys and girls. Today we're going to be talking about lesson 8.3 on area. And you might be asking yourself, what is area? Why are we learning about that? Well, first I'm going to tell you the why. Have you ever wanted to make a project and maybe couldn't figure out how much of whatever material you wanted to use to make that project you would need, or maybe you wanted your parents to get you new carpet or paint your room or something like that? Well, in order to do those kinds of things, we need to know how to calculate area. So if we take a look up here, we use area a lot of times with construction. So if you think about somebody who's going to build a home, you're going to need to know what the area of the floor is going to be so you can figure out how much wood you're going to need to make your floor and carpet it or tile or whatever it is that you're going to use to cover the floor. You need to know area to figure out how much drywall you're going to need. So there's lots of construction uses for area. And like I said, paint, if you're remodeling or wallpapering or something like that, you're going to need to figure out the area of your walls, how much you're going to cover for wallpaper. And like I said at the beginning, maybe you're doing some kind of art project and you've got to figure out the materials that you're going to need for that as well. So what exactly is area? Area is the amount of surface inside a shape. Now we talked about perimeter the other day, and perimeter was the distance around the outside of a shape. So now we're talking about the inside of a shape. So we measure area in units such as square inches, which this would be the abbreviation IN squared. We measure it in square feet. Feet squared would be my abbreviation for that. Square centimeters, again, centimeters squared, and square meters or meters squared. So you're going to see those kinds of measurements a lot, and you should be using them on your work with me in the classroom. So let's take a look at some examples. Now when we think about area and when we first start to learn how to use area in the classroom, we're going to be using two different methods to actually calculate that area. The first one is the one that we're going to focus on today, and that is the one where we're just actually going to count the squares for the shape. So that one seems pretty easy. It gets a little complicated when we have shapes like this that don't cover an entire square. So then we have to take parts of shapes and add them together to make a full square so that we can figure the area for that particular shape. The second method is to use a formula, and we're going to learn that formula in the next lesson, not today. So hold on to your horses on that one. So let's take a look at these two, actually three examples that I have up here. Now this one is pretty simple because I've kind of given you the measurements, so kind of in your head you might be able to figure that out. But if we actually count all of those squares, we have 4 down and 5 across. I could go and count each one of those and I should get 20. Or I could multiply my 4 times 5, which would be a shorter way to do that. So the actual area of this particular shape would be 20 centimeters squared, which is how we would label that. Now, when we look at this one, this is where it gets a little tricky, and this is where we might actually need to count our squares. So I'm going to grab a marker. And I have full squares, which are easy to count, so I'm going to count those first. And what I like to do is write numbers inside because it helps me keep track so I don't lose my place. Okay, so those are all my full squares. Now what I'm going to have to do is go back and count my half squares to make a whole. Excuse me. So if I look up here, I have roughly 2 halves, so I'm going to put an 8 in both of those squares because I counted 7 full squares, so this would make my 8th. These 2 would make my 9th, and you have to ignore my drawing. I know it's not perfectly square, but just pretend. These 2 would make my 10th. This one and this one would make my 11th, and this one would make my 12th. So the area for this particular shape would equal 12, and we're going to call that inches squared, okay, because we've got to put our label on there. That's how I would calculate the area for that particular shape, especially when we don't have full squares. This one is also similar to that, where we would have to go through and count. So we're going to do the same thing. So I've got full squares here. Okay, I have 18 full squares. We're going to say that this one and this one makes 19. This one and this one, I know that's not a full regular square, but just pretend. 20 and 20. This and this makes another half, and a half makes a whole. And then my last, which that's really off scale, but just pretend. And so I've got 22. So this particular shape is going to have an area of 22, and we're going to say, again, inches squared. Okay? So you might be asking yourself, well, what do I do if I have some left over? Like maybe your two halves don't make a whole, or you're going to have some shapes that actually aren't half. So you might have a quarter. So you might actually have a time when you would have like 22 and a half or 22 and a quarter for your answer. So we're just going to do our best with those particular problems. Okay, so your warm-ups today, we have 6 addition problems that you'll need to go ahead and record on the paper where you took some notes. And we didn't really have we had the one vocabulary word today, so hopefully you took some notes on area. Maybe looked at some of those problems and wrote down the different methods that I mentioned earlier that you can use to find area. And like I said, the next lesson we will actually learn a formula for finding areas. So bring those problems to school the next time we have math, and I will see you in class.